Hello all. In the series of covering SAT topic, this is our 18th video where we will discuss about properties of plane and solid figures. So first we will start with quadrilateral. So in quadrilateral, basically we will be discussing about some of the figures. Like first we will discuss about parallelogram, rectangle, rhombus and square. Let's start with parallelogram, then rectangle, then we have rhombus and square. So what we can do from here, we will discuss this in table form, where we will discuss the properties, all these four types of quadrilateral. Let's start with parallelogram. So in parallelogram, what we have to know first is opposite sides are parallel and equal. First is opposite sides are parallel and equal. Here also opposite sides are parallel and equal. Opposite sides parallel and equal. Then in rhombus, all the sides are equal and opposite sides are parallel. All sides equal and opposite sides parallel. And in square also all sides are equal and opposite sides parallel. Then second property, opposite angles of parallelogram are equal. Opposite angles equal. Then in rectangle all angles are equal and equal to 90 degree. In rhombus again opposite angles are equal, and in square all angles 90 degree. Next, this one is very important. In parallelogram, diagonals bisect each other. In rectangle, diagonals bisect and are equal also, equal in length. Then in rhombus, diagonals bisect at 90 degree, that means right angle, bisect at right angle. And in square, again diagonals bisect at 90 right angle and are equal also. These are the basic properties of parallelogram, rectangle, rhombus and square. Now if we will see the area of these four. So area of parallelogram, suppose this is with base and one height will be drawn from here. So suppose this is height, then it's base times height. In rectangle, area is given by length. Suppose this is length and this is width. So it is given by length times width. In rhombus also it can be base times height, or it can also be 1 over 2 times of diagonal 1 times of diagonal 2, length of both the diagonals. And square, so the square area is a side square. So whatever the length of the side will be there, we will just square that. That is the area of square. Now next we have to discuss is trapezoid. Next we have to discuss about trapezoid. So in trapezoid, this looks like, this is the figure of trapezoid, where one pair of parallel sides will be there. So let's see the properties. One pair of parallel sides. This is the only property. Now the other two legs may or may not be equal. So this is the trapezoid. If the other two legs will be equal, then that is called as isosceles trapezoid. If other two legs are not equal, then we can just call as a trapezoid. Sum of this and this will be 180 degree. Same side interior angle, same here, same side interior angle, so 180 degree. So this is only the property of trapezoid. That's the only property. And area of trapezoid, it is given by, suppose this is base 1, this is base 2. These are the parallel bases and the height of this is, so this is perpendicular from the base, and suppose this is the height. So area of trapezoid is given by 1 over 2 times of height times of sum of parallel bases. This is the area of trapezoid. Now there can be some type of questions where you will have to do some constructions. Like here we can do the construction like we have one pair of parallel side, but we can draw a parallel line to this leg. Then these two will become parallel and this will become parallelogram. And in The other one is rectangle. If this is a rectangle, so this is a parallelogram. That means this side and this side will be equal. And if it is a isosceles trapezoid, then this will also be equal. So this will become a isosceles triangle, where you can draw a perpendicular line from here, which will basically bisect this base. So these type of questions can be asked, where you can use this property of trapezoid. Now moving to next topic, which is volumes of solid figures and properties. So we will start with rectangular box, or we can say rectangular prism. So we'll start from here, solid figures. So here we basically will have to know about areas and volumes. So let's start with rectangular prism or box. So in rectangular prism, it looks like this. It is just like a box. Now in this box, suppose this is our length, this is width, and this is height. So volume of rectangular prism is given by L times W times H. Then see, this will be the longest diagonal from this corner, that means bottom corner, to top corner of the opposite side. That will be the diagonal, that is the longest diagonal, which we can say will be L square plus W square plus H square inside root. And surface area here will be 2 times of LW plus WH plus HL. This is about rectangular prism. Then cube. Cube is basically, you can say, a square box or square prism. So the diagram will be like this only, just that it will be a square. It is based on rectangle. This one will be based on square. So volume here will be, so since it will be based on square, so all the sides will be equal. So volume is A cube, that is side cube. Then diagonal will be also, we can replacing this one only. Surface area is 6A square. Next is circular cylinder, or we can say right circular cylinder. So in cylinder, see, suppose this is a cylinder where these two are the circular bases. So volume of cylinder is pi r square h, where r is the radius. This is suppose r. So pi r square h is the volume. If we talk about surface area, then that will be equal to 2 pi r square, the area of two circular bases, plus 2 pi r h, that is the lateral area. So we can say here, this is area of bases and this is lateral area. Now moving to next, that is cone. So it's like this, where the base is again circular. Suppose this is the radius, then volume is given by 1 over 3 times of pi r square h. And here surface area is given by pi r l, where l is this slant height. This is called as slant height. If we join from here to center, then that will be a perpendicular line. So this is suppose height, then this is radius. So this length l will be, where l is equal to square root of h square plus r square. Then moving next, that is sphere. So sphere is just like a ball. It's like this. So volume of sphere is given by 4 over 3 pi r cube. Lateral area is given by 2 pi r square, whereas our total surface area is given by 4 pi r square. So these are the figures which we need to study in solid figures, and we have to know about the area and the volumes. but these things will be written in the paper. These formulas will be written. We will see the questions based on these topics in our question series video. So that's all for this video. We'll meet again in the next one. Thank you.